Hey kiddos, so if you're watching this, that means I am working virtually today, so I am available through Google Meet and through email. So if you need to get in touch with me, please do. I hope to be back tomorrow, and I should be back tomorrow. But Thanksgiving break is approaching. We have some stuff we got to get through, so I went ahead and made these videos, so that way, even though I'm not there, we can still keep learning. I'm sure you're all very thankful for that. This video, it should be posted in your Delta Math assignment, so I am able to tell who actually watched it and whether you watched, 20 seconds of it or if you watched the whole thing. So make sure you watch the whole thing, you take notes, okay? Today we are doing systems of equations. And we are learning substitution and elimination. So I don't know if you've noticed or not, but these are typically like some of the last couple questions that are on your practice Coyote exams. They focus really heavily on elimination, but I have seen some substitution ones, so we're going to cover both. This is one of the last few Coyote things that we haven't touched at all, so hopefully this will help us do better on the Coyote that's coming up in a few weeks. So we'll start with substitution. So I'm going to abbreviate it sub. And substitution sounds exactly like what you think it is. You're going to sub one variable in for another variable. So in systems of equations, you're always going to be given two equations. That's what makes it a system. And what you're going to do is you're going to solve for one variable. In equation 1. And of the two equations, it does not matter which one is equation 1. And then you're going to plug that into equation number 2. So for example, if we are given the system y equals negative 9x plus 5 and y equals negative 10x. So systems are normally presented in these little curly brackets. They don't really mean anything. That's just kind of how they are presented. And the first thing you're going to want to do is see if any of your equations already have a variable that's solved for them. So in our case, both of these are solved because they both have y by themselves. So we know that y equals negative x plus 5 according to equation 1, but y also equals negative 10x according to equation 2. So sometimes it'll already be solved for you. Sometimes you'll have to solve for it. That just means getting y by yourself. We've covered how to do that. But for substitution, it's pretty simple. In equation 1, it tells us that y is equal to negative 9x plus 5. So what I can do with that information is in equation number 2, wherever I see a y, I'm going to plug in the negative 9x plus 5. So I have negative 9x plus 5 equals negative 10x. Okay, and then we're going to be able to solve. So we're going to add 9x to both sides. That's going to give me 5 equals negative 10x plus 9x, is negative x. So divide by that, x is going to equal negative 5 after we divide by this negative 1. So since x equals negative 5, in order to find my y, I'm simply going to plug my x back into either of these equations. It does not matter which. I recommend doing the simpler of the two. So I'm going to say the simpler one is the second one. So it's going to be y equals negative 10 times negative 5, because we know that x is negative 5, so we're going to substitute that back in. That's going to give us y equals negative 10 times negative 5 is going to give me a 50, positive 50. And for systems of equations, your answers are always given in coordinate points. So coordinate point is x comma y, so negative 5, 50. That means this coordinate point tells us that if we were to graph these on a coordinate plane, that this is the coordinate point in which those two lines would intersect. Okay, so moving on to another example. Same thing if we are given y equals 6x, and then we're given 3x plus 2y equals 15. So we look to see if we have anything that's already solved for. We do. Equation number 1, y equals 6x. Y is by itself. So I'm going to plug in the 6x wherever I see a y in equation number 2. So I'm going to have 3x plus 2 times 6x equals 15. So remember, always have your parentheses, so that way you remember to multiply when you're doing this. So then you're going to simplify, and you're going to get 3x plus 2 times 6 is going to give us 12x equals 15. Combine like terms, 15x equals 15. So x is going to equal 1. So if I know x equals 1, I'm going to plug that back into my equations. Again, it does not matter whether it's equation 1 or equation 2. I'm going to plug it back into equation 1. So y is going to equal 6 times 1. So y is going to equal 6. And remember, our answer is always given in a coordinate point. X comes first, comma your y. So the answer for that one is 1, 6. So when you're practicing substitution, make sure you're being careful about not losing negative signs or anything like that. As well as if you need more examples, I didn't want to make this video too long because I know watching videos is boring. Please go into the Show Me an Example button on Delta Math. Look at some of those, copy them into your notebook, okay? It might be a lot of writing, but it's only going to help you, I promise. So I'm going to go ahead and move this off the screen. If you need extra time to copy it down, please pause the video. And then the next thing we are going to do is elimination. So for elimination, you're, again, trying to do exactly what the method title says. You're trying to eliminate one of your variables from both of your equations. So for instance, if we are given negative 4x plus y equals 23, and then we are given 4x minus 9y equals negative 15. So this is our system of equations that we're giving, and what we're trying to do is eliminate one of our variables. So what that means that you're looking for, I'm not writing this down, so make sure you write down what I'm saying, as it is important. You're looking for one of your variables, whether it's x or y, to have the same coefficient attached. So the coefficient is the number that's out in front of our variable. The signs do not have to be the same, just the coefficient value does. So if we look at this one, for our x, we have a negative 4 in equation 1 and a 4 in equation 2. Those are both forms of 4, and that is what we're looking for. So our y's, we can't eliminate our y's because this has 1 y and this has negative 9 y's. Those aren't the same amount of y's. So since we have 2 4's for our x's, that means I'm going to eliminate my x's. And the way that you eliminate things is either through addition or subtraction. So if you have the same sign, so whatever variable you're trying to eliminate, if they are both positive or both negative, you're going to subtract. If you have different signs, you're going to add. That's the main rule for elimination. So we go back over here. We have negative 4 and 4. Those are different signs, so we're going to add our two equations. So negative 4x plus 4x, that's going to give me no x's. I have to do 1y plus negative 9y. That's going to give me negative 8y. 23 plus negative 15, that is going to give me 8. So I have to get y by itself, so I'm going to divide by that negative 8. And then y is going to equal negative 1. And again, like we did in our other equations, and once we know one variable, we're going to have to plug it in to get the other. So it doesn't matter which one. I'm going to do equation number 2. We're going to have 4x minus 9 times negative 1 equals negative 15. That's going to give us 4x plus 9 equals 15, because negative 9 times negative 1. We're going to subtract that 9 over. So 4x equals 15 minus 9 is going to give us, wait, I think I might have done this wrong. Please hold. Where did I go astray? 9. Oh, it's because it's a negative 15. I'm sorry. negative 15 minus 9. See how easy it is to forget your negative signs? So negative 15 minus 9 is going to give me negative 24. And x is going to equal negative 6. So our answer is going to be negative 6, negative 1. Coordinate points as always. And if you're unsure if these are right, you could always plug them both back in. So we're going to have 4 times negative 6 minus 9 times negative 1 should equal negative 15. This will give me negative 24 plus 9 equals negative 15, which will give me negative 15 equals negative 15. So that works out. Oops, you can't see that. That works out. So this means this is a solution for this system. Moving on to another example. We're going to have 8x plus 6y equals 28. And then we're going to have 9x plus 3y equals 39. So for this one, if we're looking for our x's, we have an 8 and a 9. Those aren't the same. We have a 6 and a 3, and those are not the same either. So what we're going to have to do is figure out which of these equations we can easily turn into the number that we need, if that makes sense. So you cannot easily turn an 8 into a 9 or a 9 into an 8. But we can easily turn a 3 into a 6 by multiplying by 2. So you're going to multiply this whole equation by 2. So 9x times 2 is going to give me 18x. 2 times 3y is going to give me 6y. And then 2 times 39 is going to give me 78, I believe. Yes. Then I'm going to bring my other equation down. So 8x plus 6y equals 28. My y's have the same value in front of them, but they're both positive. So same sign, subtract. Going to be subtracting for this one. 18x minus 8x is going to give me 10x. 6y minus 6y, that's going to cancel out my y's. 78 minus 28 is going to give me 50. So x is going to equal 5 after you divide that 10. Again, we know what x equals. We don't know what y equals, so we're going to have to plug that back in. We're going to have 9 times 5 plus 3y equals 39. I always recommend plugging it back into your original equation. That's going to give us 45 plus 3y equals 39. Let's see, we're going to subtract over that 45. So 3y is going to equal negative 6. So y is going to equal negative 2. So our coordinate point for this one is 5, negative 2. So in a nutshell, that is elimination and subtraction. I hope you found this helpful. Please make sure you are watching this video and taking notes and doing your work. Even though I am not in class, I can tell who's logged in, who's making progress, and who's not. So even though I'm not there, expectations are no different. If you do have questions, please feel free to email me, Google Meet me, whatever you need. And I hope you all had a lovely weekend and you have a great day today. And thank you to those of you that worked really hard on Friday. Congratulations to Jalen, as he was the only one that passed the Practice Coyote. And I can also see how long you all took to do those. So thank you to those of you that actually took, at least 40 or more minutes to do so. I greatly appreciate it. We can talk more about that when I come back. So if you have any questions, please reach out. Hope you found this helpful. Hope you get some progress done today. And I hope to see you all tomorrow. Ooh, sorry. See ya.